Welcome back to the classroom. Today's topic is the study of difference between 8-bit and 16-bit microcontrollers. First one is introduction of microcontrollers. Microcontrollers are small computers that are designed for specific tasks and operate with low power consumption. They are commonly found in embedded systems like household appliances, medical devices, automotive systems, and industrial control systems. There are different types of microcontrollers available, varying in terms of processing power, memory, and input output capabilities. Two common types of microcontrollers are 8-bit and 16-bit microcontrollers. The main difference between them lies in the number of bits they can process at once. An 8-bit microcontroller can handle 8 bits of data at a time, while a 16-bit microcontroller can handle 16 bits of data at a time. This video sponsored by Genreviews. 8-bit microcontrollers are frequently used in low-end applications that do not require significant processing power such as remote controls, toys, and simple sensors. They usually have limited memory and input-output capabilities, and they are relatively inexpensive. On the other hand, 16-bit microcontrollers are utilized in more complex applications that demand higher processing power such as motor control, data logging, and advanced sensors. They typically have larger memory and input-output capabilities, but they are also more expensive compared to 8-bit microcontrollers. A microcontroller is a chip that contains a processor which is essential for processing data. Without a microcontroller, a processor is rendered useless. The term 8-bit microcontroller means that it can read and process 8 bits of information, while a 16-bit microcontroller can handle 16 bits and a 32-bit microcontroller can handle 32 bits and so forth. Next is the study of 8-bit microcontroller. An 8-bit microcontroller is a microcontroller that has a data word length of 8 bits only. The word length or word size of a microprocessor refers to the number of bits it can process simultaneously. Next is 16-bit microcontroller. An example of a 16-bit microcontroller is a device capable of processing data and performing calculations using 16-bit at a time. This enables it to handle larger amounts of data and computations simultaneously. Additionally, it consumes less energy and operates at a faster clock speed compared to an 8-bit microcontroller. As a result, it has become the most commonly utilized microcontroller in various applications. Next is the difference between 8-bit and 16-bit microcontrollers. Number 1. An 8-bit reading bus is present on 8-bit microcontrollers, but a 16-bit reading bus is present on 16-bit microcontrollers. Number 2. 8-bit microcontrollers have a lower clock speeds but are more reliable. But in 16-bit microcontrollers offer double the clock speed but are less reliable. Number 3. 8-bit microcontrollers are less efficient than 16-bit microcontrollers. Compared to 8-bit microcontrollers, 16-bit microcontrollers are more efficient. Number 4. 8-bit microcontrollers require more ROM, but in 16-bit microcontrollers require less ROM. Number 5. Microcontrollers with 8 bits take up less space than microcontrollers with 16 bit. But microcontrollers with 16 bits take up more space than microcontrollers with 8 bits. Number 6. The 8-bit microcontroller is cheaper, but 16-bit microcontroller is costly compared to an 8-bit microcontroller. Number 7. The 8-bit range for each instruction cycle is 0 to 255, but in the 16-bit range for each instruction cycle is 0 to 65,535. Number 8. An 8-bit microcontroller takes 20 milliampere of electricity to operate, which is twice as much as a 16-bit microcontroller's current consumption. But in 16-bit microcontroller takes 10 milliampere of current. Number 9. 8-bit input and output peripherals are less advanced than 16-bit microcontroller input and output peripherals. But 16-bit input and output peripherals are more advanced than 8-bit microcontroller input and output peripherals. Number 10. At 48 MHz, an 8-bit microcontroller shows a speed of 12 MIPS. At 32 MHz, a 16-bit microcontroller shows a speed of 16 MIPS. Number 11. Microcontroller with 8 bits have 8-bit reading bus, but microcontroller with 16 bits have 16-bit reading bus. Next is the features of 8-bit microcontroller and 16-bit microcontroller. Number 1. Data bus width of 8-bit microcontroller is 8 bits, but data bus width of 16-bit microcontroller is 16 bits. Number 2. Memory address width in 8-bit microcontroller is up to 64 kilobytes, but memory address width in 16-bit microcontrollers is up to 4 GB. Number 3. Processing power in 8-bit microcontroller is limited, but processing power in 16-bit microcontroller is higher. Next is input-output capabilities of 8-bit microcontroller is limited, but input-output capabilities of 16-bit microcontroller is higher. Next is cost. Cost of 8-bit microcontroller is inexpensive, but 16-bit microcontroller is more expensive. Next is applications of 8-bit microcontroller is simple sensors, toys, remote controls, but applications of 16-bit microcontroller is motor control, data logging, and advanced sensors. This is the brief study of difference between 8-bit and 16-bit microcontrollers. Thank you for watching.